the catastrophic effects of detonating all nuclear weapons. As of now, the world possesses approximately 15,000 nuclear weapons. The United States and Russia dominate this arsenal, each holding close to 7,000 nuclear weapons. The remaining 1,000 weapons are spread among 7 other countries: France, China, the United Kingdom, Pakistan, India, Israel, and North Korea. But what exactly does this figure represent in terms of destructive potential? Visualizing the destructive force. To understand the magnitude of these figures, let us put them into perspective. On Earth, there are about 4,500 cities or urban regions with populations of at least 100,000 individuals. If we assume an average of 3 nuclear bombs are needed to completely annihilate one city, it becomes apparent that the current nuclear stockpile is sufficient to obliterate every significant city on Earth, resulting in the deaths of around 3 billion people, nearly half of humanity, in an instant. Even after such widespread devastation, approximately 1,500 nuclear weapons would remain. Understanding the explosion magnitude, the average American nuclear warhead has an explosive yield of around 200,000 tons of TNT. Combined, 15,000 such warheads would unleash an explosive force equivalent to 3 billion tons of TNT. For context, this amount of explosives could rebuild the entire island of Manhattan, including all skyscrapers, using bundles of dynamite. Pressing the detonation button. Now, imagine the countdown to detonation has begun. 3, 2, 1. When the button is pressed, immediate aftermath. Within seconds, a massive fireball with a diameter of 50 kilometers would incinerate everything in its path, creating a shockwave that would flatten 3,000 square kilometers of rainforest. All life within a 250-kilometer radius would ignite. The explosion would be audible worldwide, with pressure waves circling the globe multiple times in the following weeks. Millions of tons of combustible materials would be blasted into the atmosphere, creating a colossal mushroom cloud reaching the outer edges of the stratosphere and beyond. Formation of a crater and radiological hazards. Post-explosion, the impact would leave behind a crater with a diameter of approximately 10 kilometers. At the center of what could be described as the most catastrophic forest fire Earth has seen in millennia, spreading across South America and incinerating forests and cities alike. Highly radioactive material would immediately render the area around the crater uninhabitable. Similarly, regions hundreds of kilometers downwind would also become hazardous for life. Global spread of radioactivity. This intense, localized destruction would not be the end of the fallout. Radioactive particles would be lofted high into the atmosphere, proliferating globally. While this wouldn't spell the end of civilization, a surge in cancer cases worldwide seems inevitable because of increased environmental radioactivity. Nuclear winter scenario. A fraction of these radioactive particles would remain suspended at the fringes of space for many years, inducing a nuclear winter. This climatic anomaly would result in a temporary global cooling effect, decreasing temperatures by several degrees for a few years. Catastrophic immediate effects. An unimaginably vast fireball would ascend, visible across half of South America. The explosion's unprecedented force would pulverize the Earth's crust like water, forming an enormous crater 100 kilometers wide. Mountains would vaporize instantly, with debris ejected into the cosmos. Much of it would return, cascading back down as searing, molten rock, raising global temperatures to furnace-like levels, annihilating larger animals and sparking worldwide firestorms. Radioactive Earth, a lifeless desert. In the ensuing cataclysm, every corner of the globe would be enshrouded in radioactive debris. While the planet itself might not be irreparably harmed, life as we know it would cease to exist. The few human survivors, possibly sheltered in deep bunkers or submarines, would face a desolate, frozen